Hello everyone and welcome back to my channel. In this video we're going to be talking about DQL, DDL and DML. So let me just put that down. DQL, DDL and DML. We want to understand what these acronyms mean and how to recognize them actually. So the first one, DQL, means data query language, and it's just SQL you use to query data or to extract data from your tables. Just like in the practice video that we did the last time, if I remember correctly, all of the queries that we ran were all select statements. We were just extracting data from a table. So all of that would be DQLs. DDLs, data description language, and these define the structure of the data. And this would include all create statements. Like when you create a table, you also create the columns and then you define the domains for the columns. That is data description language. Then for DMLs, that will be your data manipulation language. And we use that to define and to update the data. For example, if you want to drop a column, add a column, change a value, all of that will be data manipulation language. The thing is, all of these are all SQL, but they're just various commands that do various things in SQLs. So let's start with a select statement from our account table. So we have account table is in the bank schema, account table, and it has 4 columns. So let's say we want to select everything from our, we want to mention our schema first. So when you run this, you have all these values. You can also add a conditional, right? I'm sure we talked about conditionals in the last statement. So you can say where type, that's the name of the column is type, where type equals, let's say checking, right? And when you run that, you have information for only checking account. And I do remember we talked about aliasing a bit. This is just a refresher. Let's say in my result set, my new table, I want a more descriptive word for the names of this column. So instead of number, we can say account number. So you say select number as, use the as keyword to assign a new name to the to your column in your result set. So you say as, we want to call that account number. And we also want to select owner, but we're not so happy with that name. So we say owner as customer name. Customer name. And when we run that, yay. So this is what we have. Account number and customer name. And this is clearer, if you ask me. So moving on, let's talk about aggregate operators. And with our select keyword, we could use aggregate operators like max, min, average, we have count. All of these are aggregate operators. Max meaning maximum number from a set of numbers. Min meaning minimum numbers from a set of numbers. Just I do know they are familiar with these terms though. Count counts all of the values in a column or in a table, depending on what your parameter is. So let's check out min. Let's say we want to find the mean balance a customer has in this bank. So we can say mean balance. Let's run that. Oh, the smallest amount is 1,500. If we wanted to check the maximum amount, we would say max. So let's also check out count. We want to count how many customers we have. So that will be count owner, right? Oh, can't spell owner. Count owner. So we have about 8 people. So very quickly, let me mention that the count keyword counts duplicates too. So let's say in your table you have duplicate values or duplicate rows. The count will count everything as well. But to remove any form of duplicity, you use the keyword distinct. So I'm not sure this would work here because all the customers are different, but this is distinct keyword, like distinct, distinct. So yeah, so when you run this, it gives you unique values. So distinct owners, and then it counts them. They are still it. Yes, and one other thing to mention is whenever you use aggregate functions, you do not combine it with let's use count for example. You do not combine it. You do not try to extract it alongside with another column that has more than one value. For example, count whatever column or max whatever column, min whatever column would return only one row, one answer, just one value, just like this. But supposing this column owner would return as much as 8 values. If you run this SQL statement as is, it's in fact it's illegal. That's what it's called. It's called an illegal SQL. It's not going to return anything, and that's because the value from owner and the value from one are not equal. So that's one thing to note. The only case where you can return an aggregate function alongside with another column that has more than one value would be when you use the keyword group by. We haven't talked about group by. We will talk about group by in a future video. So let's move on to like. There's a like as a pattern matching. So let's remove this very quickly. So let's run this. So let's say we want to return all customer names that have, let's say, A in them, maybe like Grace Miller. So when you extract the select, when you write the select statement to extract the owner, you include a conditional. So you say where owner like, so you would use, and in this case, we do not care whether the letter A is at the front or at the end of their name. We just want all names that have the letter A. So we have the percentage A and then the percentage. And when we run this, it returns all names that have A. But if we wanted all names that only starts with A, maybe like Alice, right? Do we have an Alice? I'm not so sure. Anyway, if we wanted all names that starts with A, or we don't. Oh, we don't. Okay. And all names that end with an A, you run this. We don't have names that end with an A. So we only have names that have A somewhere. Okay. Let me look at our names again. So we're supposed to have Alice somewhere. So let's check this again. Where owner like, okay, so this actually matches the case of the words. So when you have lowercase a, it doesn't return Alice because I thought we had an Alice. But if you used uppercase A, it does return an Alice. So this is a key takeaway I want you to note. When you want to return a letter, um, that's not the beginning, neither is it the end of the word. You use your percentage, that later percentage inside your apostrophe, your quotation marks. But if you wanted to return a word that ends with a particular letter, you would have percentage and that letter. That's it. If you wanted to return a word that starts with that letter, you'd have, just as we have here, that letter and percentage sign. That's it. So we can go one more step if we don't want this to be case sensitive, because as is, it is case sensitive. To remove case, to remove that, you can add an I in front of the like. So you have ILIKE, and when you run this, yay, even with a lowercase letter a, it returns Alice. Okay, that's a lot already. Let's go to DDL. So for DDLs, that's your data definition language. That's primarily going to be the create statement. Um, so when you create a table, this video is going to be dense. Okay. So when you create a table, you use your create keyword. So you have create, the name of the table, the name of the table. Let's say we want the name of the table to be students. So this, and then you open the bracket. So this basically creates a table for you, but and if you create this table in this way, it puts it, that is if you're using a pgadmin 4, it puts it in the public schema. But if you wanted to create a different schema for it, you would have to start by creating a schema first. But basically, this creates a table. So when you write your create table, name of table, you open a bracket, and inside that bracket, you start writing the names of your column. So first of all, I want to have an ID, and we've talked about, I'm very sure we've talked about creating tables before, so this is just like a recap. So if I wanted to assign to my ID columns serial numbers like 1, 2, 3, 4, 5, 6, all the way to the end of the data, I would have serial, and this of course would be a primary key, serial primary key, right? Then your comma, the next let's say name of the student, and I want this to be a varchar, and I never want it to be null, so not null. And so you're just going to continue in this way until you define all your columns and their data types and all that. So this is defining price. I don't know why I would have price, but yeah, let's say yeah, school fees, right? Instead of price, I should just say fees. Fees. So it runs in 19 digits. Wow. With 2 decimal places at the end. So, and I never want it to be null. So we have not null. And in cases where there are no values, I want it to be 0. So you have default 0. So you're going to continue in this way until you define the table. So this is what it is. So when you run this, let's run that. So when you run this, you've defined the table. Let's go to public. Let's look for the tables in public. Yay, we have a student table. So that's how you define a table. And like I mentioned at the beginning of this playlist, the the flavor of SQL you're writing right now is Postgres. That's PSQL. If we're writing MySQL, we'll probably say int auto increment primary key. But for PSQL, that's simply just going to be serial primary key. So we've talked about keys earlier. If you need a refresher on that, please go back to, I think, the first video where we talked about primary keys. We talked about surrogate keys and all that. We really did talk about keys, so maybe just check that out. If you noticed, we used some keywords like, of course, primary key. This defines the primary key of the table. Not null. simply saying we don't ever want this column to not have a value. Default, simply saying if it does not, still saying we don't ever want it to not have a value, and if it does not, fill it up with 0. So there are some keywords that can help you define your columns exactly in the way that you want it to be defined. So still under DDLs, of course, I think we've talked about different data types we did in the first video. So please also check it out. That's going to help you define all your, for example, this is a varchar. So we use varchars for like names, anything that's like textual, right? Decimal, mainly numbers. We also have integers and all that. So maybe just check it out. So we have just defined this table called student, and like I mentioned, this is under the DDL, right? And if we wanted, we could create another table. Let's create another table, and that's because I want to show you how to define. We talked about foreign keys, which references another column in another table. So let's quickly talk about how to get that defined and done. So let's create this other table. We're going to call it details, maybe details of the student, something like that. So create table details, and as usual, you open your bracket. You want to start with ID, and like I said, ID serial primary key. You always define your primary key for each table. That's very important. So let's say we have PID, or should I call it SID, right? Let's say SID, which means student ID. So it means that yeah, I'll just call it SID. It's going to be an integer. Integer is a data type, and my intention is that SID references the ID column in the student table, right? So, but we're just going to see that come into play in a minute. So we have another column called text, and it's going to be a text data type. Maybe we should come up with a better name. Let's call this detail. No, info is a better name. Information about the student, and it's a text data type. So I did mention that I wanted seed to reference ID in student table. So I'm just going to say foreign key, and in bracket SID references student. So this is how it goes. Foreign key SID references the student table. So, oh, you don't have a semicolon here. So after this, you have your semicolon. So if you, of course, remove this, run this, it creates another table, and that defines this foreign key. So this is still on the DDLs. If you wanted to delete a table, you see still under DDLs, you can decide to drop a table. So when you drop a table, you eliminate the table from memory and from storage, just like delete, right? So you can say drop table, the name of the table. But before that, let's check out how to drop a column. You can say drop let's see. Okay, let's just drop a table first. I think that's I want to drop the student table. So let's say drop table called student semicolon. And if you run this, you'd have, yeah, it's dropped. But I'm still seeing it here. So you just might want to go to the schema. You want to refresh this. So go to schema. Where's that? up there, right? Yep, schema. You want to refresh. Yes, and once you refresh, you come back to public, you no longer have any table. So student table is deleted. All right, so that's for the DDLs. So one other thing I was going to mention is there's another keyword called if exists, and we use if exists. It's really useful in production because it eliminates errors that makes dropping a table idempotent. So um so instead of saying it's usually a better practice, instead of saying drop table student, I could have just said drop table student if no drop table if exists student. So what this does is it it helps us avoid unnecessary errors. So before a table is dropped, you want to check that that table exists first. If exists, you have an S. You want to check that that table exists first, then you drop it. So you just want to avoid errors. And you also, it's even more useful when you want to create a table, let's say student, because at some point, all of my schemas and the data in it and data in it um, could become so complex that I've lost count of what I have and what I do not have. So before I create a table called student, just like I just created, the first statement, it would be more correct to say drop table if exists students. Then I go ahead to create table students, if that makes sense. So when you drop if exists before you create, it prevents an error. Let's say if you just wanted to create a table called student without checking if it exists in the first place, you're going to have an error. So it's not going to create. Your code just, that's wasted time and wasted error. You could have just dropped if exists and then created. So that's that for DDL. So now let's move over to DML. So DML will be data manipulation language, and like I mentioned, we use DMLs to manipulate data. We use it to insert values in a database, just any form of manipulation to update a table, insert values, remove, drop column, all of that fall under DMLs. Let me catch my breath. Okay, so DMLs, like I said, to insert values. So normally after you create your tables, you insert values. So the insert statement, we've gone through this before, just looks like this. You can say insert into student. Our student table no longer exists anyway, but this is just an example. Insert into student values, then some values. Let's say 3. I think we had student name. Let's say her name is Vera. Something else about the student. I can't remember all the columns that we had, but let's say we had age, right? So, oh, I remember we had fees, something like that. Okay, but let's say she's 50 years old or she pays 50. So this is what it would look like. So you either write it this way or immediately you say, this is valid. I'm just going to duplicate this. This is also valid. Insert into students. You want to define the names of the columns that you want to add values to. Let's say name. I want to add values to column name, and let's say under column called age, right? So this is also valid. And in this case, you want to remove this. And remember, it's okay if you do not, or if you do not manually write numbers to fill in your ID column. And that's because when we defined the table, when we defined the ID column, we said we wanted serial numbers. So it's going to automatically fill up. So this is valid. Yeah, and if you had many values, you could just go on listing all those values. So you say insert into students and bracket the names of the columns, then values, the values that you want, and all that values. So it's just as simple as that. So we can also delete um table, right? Or in this case, data manipulation language, we can delete a row. So we can say delete from student where ID equals, let's say, 1, right? And when you run this, it's, let's say, so okay, that's not ID. Oh, we have number in this. Okay, this is not valid for this. This is not valid for this table because we don't even have an ID column. Okay, let me stick to students. Just makes it simpler to explain. Okay, so remember our student table has the ID column, the name of the student, and age. So if I wanted to delete the first row where ID, of course, is 1, this code does it, and this is a manipulation language because it just manipulates data that you already have. So we also have the alter keyword. And the alter keyword, what it does is that it allows you to add columns, allows you to delete, to drop columns or to delete columns. It allows you to add keys, add foreign keys, and other constraints in your data. So it's extremely flexible, and sometimes it's used in unexpected situations. So let's look at the alter keyword. So simply written like this: alter keyword. So you alter table, the name of the table. So let's say we're still altering student, and we wanted to add another column to students. So I think I should just go ahead and create that student data, that student table again. So create, I should have just copied it. Create table student, and I had an ID serial primary key, and I had, if I can remember correctly, name. I wanted it to be a text or varchar, something like that. And let's say age, and I wanted it to be an integer. Yeah, let's run with this. Yeah, so right now, if you refresh this, would have a student table again. So we can just check by saying select all from student. If you did that, I mean, there would be no data, but this is everything we just created right now. So let's say we wanted to add one column to this student table. So you use the alter keyword. You have alter table. Table is called students, and I want to add alter table student. Let's say I want to add, let's say, student fees, right? So let's add, the name of our column will be called fees, and it's going to also be let's it just be an integer, but that's not the most ideal for fees. You could just use decimal. So we want it to be an integer, and let's say we want a default value to be 500. So what this does is it's going to add a new column, and it's going to fill it up with 500, all things being equal. So, but you know what? Select everything from students. Yeah, I didn't expect it to actually put 500. The reason is because there is no information in this table already, but supposing we had information and then we added a new column and said default 500. Supposing we had, let's say, 5 rows already, it's going to fill up the column for fees in those 5 rows as 500. So just, letting you know. So we also have the updates. So what update does is it enables us to update existing rows. Now I'm tempted to add new rows now. Okay, this so this is how updates would work. So you want to say updates student. I'm not going to run this because there is no existing rows right now, but this is how it would work. You want to update student, then set let's say where ID is 1, right? Oh no, let's say you want to, this is a better use of it. You want to set ID equal 1. No, let's set name. Let's say we already had the first name here. Let's say Vera, right? We already had the first name here, Vera. So we want to set name equals, let's set it to Martha. Where, so this is the conditional now, where ID is equals 1. So what this would do is, supposing we had Vera here in the first place, it would change it from Vera to Martha, where the ID is 1. So that is how the update works. And if we wanted to drop one column, we could do that. That's still an alter. So we're going to alter table called student, and we want to drop the column called fees. And if we run that, yay. So you have, no. So you have select all from students. You no longer have, yes, the fees column is out, so out. And I think we are going to end this video here, and that's already a lot. And I did hope that you picked something from this video. If I were to mention, I'll just mention, one last thing. Let's say I wanted to add a column. We already tried adding a column to this table. Let's say I wanted to add a column that would be update, right? Alter table, student, add whatever your column name is. And if we wanted to, so yeah, I remember now. When we added a new column called fees, we defined it in such a way that by default it would be 500. But let's say we wanted it to be on a case by case, let's say, um, alter table students, and I want to add fees, and I defined it as integer, and let's say I had ID. On the ID column, I had IDs 1, 2, 3, and I wanted the fees to differ by the ID number, or more realistically, by maybe the name of the student, because I know their class, or most realistically, by the age of the student, right? So I could say, alter table, I've added the column. The next thing I could say would be update the column, which is fees. I'd go update fees, and the next thing I would say is set So the next thing I'd say is, sorry, this would be update table, not update fees. Update table name. Then I want to set the column name. Set fees equals case. So I want to set um on a case by age, right? So case age. Then I'd say when, let's say the age, when age is, let's say 2, then I want the fees to be 700 because childcare is so expensive. When age is 5, then I want the fees to be, let's say, 500 because miraculously it reduces when as the child gets older. And let's say when the age is 10, then nothing. It's free childcare. Then 0. Yay. So you add an end. Yeah. So we've talked about a couple of things under data manipulation. I'm just going to tie it up. Under data manipulation, we inserted values into a table, right? And then we talked about deleting rows. So you delete from a table where you state your condition, maybe where your ID is 1 or whatever. So you can also alter table, and altering table means you want to add columns, you want to drop columns and all that. So it simply goes like you have on the screen, alter table, the name of the table. Then if you're adding column, add column name, define the column data type. So you have this for adding table, deleting table. That would be an alter keyword. Then for updating helps you to update rows, already existing rows, or columns, right? So, or rows in a column. So you can have, just as we have here, update name of table. So update students. You want to set the column fees equals kid age. You want to update fees based on age. This is how you get it done. If you want to update a particular row, you could say update name of table, set, let's say name equals matter, where PID is equals 1. So it changes whatever it was that was there before now. We're just going to end this video here. I hope you did enjoy it. Our next video would be a practice video on everything we have done here so far. We're just going to practice, practice, practice. So I'll see you on the next one. And if you have not subscribed, please do remember to subscribe. It's totally free. Thank you.